Good morning, all of you. Now, today we are going to study about the next topic of the chapter, real numbers, and the new topic will be about the rational and the irrational numbers. Remember, students, as per the examination point of view, this topic is very, very, very important because we can expect either a 3 marker question or a 4 marker question from this particular topic only. To start with, first of all, we should know what do you mean by rational and what do you mean by irrational numbers. Any number uh, which cannot be expressed in the form of p by q. I repeat, any number which cannot be expressed in the form of p by q are known as the irrational numbers. It means the rational numbers can easily be expressed in the form of p by q. Now, let us directly start with the questions part, and the question is that we have to show that a root 2 is irrational. Um, for this particular question, you have to remember the steps because in the examination we can have show that root 2 is irrational, or root 3 is irrational, or root 5 is irrational, or even root 7 is irrational. Anything we can get. The steps will remain same, only the figures are bound to change. Just go through the steps very thoroughly. Now, the starting step is, instead of assuming it to be irrational, we will assume its contrary. Contrary means the opposite one. So let us assume to the contrary that a root 2 is irrational. See, here we have to prove that root 2 is irrational, but what we are assuming is root 2 is irrational. Second step, now if it is a rational number, definitely it can be expressed in the form of a ratio. Hence I am writing here as, let root 2 be a upon b, where a and b are co-prime numbers. Uh, a new word, co-prime numbers. What do you mean by co-prime numbers? Numbers are co-prime if the only positive integer or the factor amongst them is 1 only. It means, let us say any example, 5 and 6. Now these two numbers are co-prime numbers because the only factor that divides both is 1 only. You cannot have any other number. Similarly, 2 and 5. 2 and 5 are also known as co-prime numbers. The reason is both of them share only one common factor, and that is 1. Now, the next step in this, uh, what I'm going to do is I'm going to express a in the form of b. Therefore, this a can be written as root 2b. Root 2 into b is equal to a. The next step is we just square both the sides. Hence, we can write this as root 2b whole square is equal to a square, or we can also say this is equal to 2b square is equal to a square. Therefore, we come to a conclusion using this equation that a square is divided by some number. It means a square upon 2 can be written for this b square. Now, if this a square is divided by 2, we can also say that a can also be divided by 2. Hence, we can write a is equal to 2c for any integer c. Now, why I am doing this? I am doing this because from this equation we can get b square is equal to a square upon 2, which means that b can be expressed as a square upon 2. If a square can be divided by 2, hence a can also be divided by 2. And if a can be divided by 2, we can write a is equal to 2c for any integer c. I don't know this value of c here. We never know this value of c. It is just meant for expressing it that yes, a can be expressed in terms of c also. Now if I square this, I can get a square is equal to 4c square. A square is equal to 4c square. Now I have two values for a square. One is a square is 4c square, and here we have a square is equal to 2b square. I repeat, I have two values for a square. One is 2b square and the another one is 4c square. Now if I substitute the values of a square, we can get 2b square from here and 4c square from here, or we can say 2b square is equal to 4c square. A square is 2b square here and a square is 4c square here. Hence we can say 2b square is equal to 4c square. Now if I cancel out this 2 and 4, I can get b square is equal to 2c square. Now another conclusion. Here I have written b square as a square upon 2. Here I have written b square is equal to 2c square. It means that 2 divides b square, and if 2 divides b square, we can also say that 2 divides b also. Therefore, we come to another conclusion where we can say a and b have at least 2 as a common factor. How? Coming back, a is having 2 as a factor, a is having 2 as a factor, and here b is also having 2 as a factor. Whereas the co-prime numbers say that they cannot have any common factor among them other than 1. But here we are having 2 also. It means 1 is there as well as 2 is also there. But this contradicts the fact that a and b have no common factors other than 1. This contradiction has risen because of our incorrect assumption. What was the incorrect assumption? The incorrect assumption was that we have assumed that root 2 was rational. And because of this contradiction, we will say that root 2 is irrational. I hope it is clear. Let us try to understand the same question again by changing the values. So I have taken here, show that root 7 is irrational. Again, starting with the same fact, let us assume to the contrary that root 7 is rational, and if it is rational, it can be expressed in the form of a upon b, where a and b will be taken as co-prime. You know about the co-prime numbers. Co-prime numbers are those numbers which have only the common factor among them as 1. No other number can be there. Or I can say root 7 into b. By this cross multiplication, root 7 into b will be equal to a. Next step was squaring both sides. We can say root 7b whole square is equal to a square, or we can say this 7b square is equal to a square. Therefore, we come to a conclusion that 7 divides a square. Now, if 7 divides a square, 7 will also divide a. And for that, we can write a is equal to 7c for some integer c. We don't know the value of the c. It is just here for expressing it that yes, a can be a factor of c along with 7. Hence we can have a square as, from here we can have a square as 7b square, and from here we can have a square as 49c square. I repeat, here we have a square as 7b square, and from here we have a square as 49c square. Means we have two values for a square, 7b square and 49c square. They can be equal because they both are the values of a square. Hence we can say b square is equal to 7c square by cancelling out this 7 to this 49. Now we have two values of b square. Now if 7 divides b square, we can also say that 7 divides b also. Now a and b have at least 7 as a common factor. Going back again, let us see how. Here we have written that 7 divides a square. We can also say that 7 divides a. So a is having a common factor as 7, and here b is also having a common factor as 7. Now a and b both cannot have any common factor other than 1 because they have been assumed as coprime. Hence, there is a contradiction. Therefore, we can say that root 7 is irrational number. Now, the third question of the same category. Now, show that 3 plus 2 root 7 is irrational. Although the steps will remain same, you have to follow this. To start with, we have first assumption, which will say that 3 plus 2 root 7 is rational. If it is rational, then we can express it 3 plus 2 root 7 as a by b, where a and b are coprime. Remember what I have told you about the coprime numbers. Or I can also say now, here 2 root 7 can also be expressed as a by b minus 3. Next step, by taking the LCM, we can have b as a LCM. We can say this is a minus 3b upon b for 2 root 7. And 2 can be here also. In the next step, we will write this only, that root 7 is a minus 3b upon 2b. Our aim is to separate out the values which are under the roots. I repeat, in any question, our aim is to separate out the values which are under the roots. Now, a minus 3b upon 2b is a rational number. We know it because a and b are integers. Now, if a and b are integers, we can write a minus 3b upon 2b as a rational number. Now, if this is rational number, this has to be rational number. It is a theorem which will say that any rational number on the either side of the equation will be equal to the another rational number on the other side. Now, if this is rational, this has to be rational. But we know that any such values which are under roots are always irrational. But this contradicts the fact that root 7 is rational. Hence, we can say that 3 plus 2 root 7 is irrational. Uh, that's all for today. I hope you have understood this. As per the examination, these questions are very, very, very important. Definitely, we are going to have a question on this, either of 3 marks or 4 marks in any of your examinations, either internal or in boards. Thank you. Stay healthy, stay safe.